You think the atomic bomb won the war? Think again. It was actually a tiny copper puck hidden inside a wooden box. It hunted invisible U-boats, saved Britain from starvation, and today it is sitting right on your kitchen counter. Here is the true story. October 18th, 1940, 200 hours, the North Atlantic approximately 300 miles south of Iceland. The air smells of freezing salt spray and burning bunker oil. It is pitch black. A darkness so absolute that the horizon line has dissolved, merging the ink-black ocean with the starless sky. Down in the water, rocking violently in the swell, is the German submarine U-99. In the conning tower, Korvettenkapitan Otto Kretschmer, the silent Otto, raises his binoculars. He does not need to worry about being seen. He is running on the surface, his diesel engines thrumming a low, confident rhythm. To the British escorts protecting convoy SC-7, he is a ghost. Their ASDIC sonar only works underwater. Their eyes are useless in this suffocating gloom. Kretschmer smiles. Ahead of him, a fat merchant tanker is silhouetted against the burning wreckage of a ship he torpedoed 10 minutes ago. "Tube 1 fire," he commands. The submarine shudders slightly. Seconds later, a geyser of fire erupts into the night, another ship broken. Another few thousand tons of vital supplies, food, steel ammunition destined for a besieged Britain sinking to the bottom of the Atlantic. This is the happy time for the U-boat crews. They are slaughtering Allied shipping with impunity. They attack at night on the surface where they are faster than the corvettes trying to hunt them. They are winning the war because they possess the ultimate cloak of invisibility, the dark. The British Royal Air Force patrols these waters, but their aircraft are blind. The radar sets currently jammed into the nose of a Sunderland flying boat or a Hudson bomber are primitive forests of antennas. They operate on a 1.5-meter wavelength. They are messy, weak, and suffer from so much clutter from the sea waves that a low-profile submarine is impossible to distinguish from the ocean itself. Britain is bleeding out. If they cannot find a way to strip the darkness away from the U-boats, the island nation will starve. September 19, 1940, the Shoreham Hotel, Washington, D.C. 4,000 miles away from the freezing Atlantic slaughter, the air is thick with cigar smoke and humidity. In a private suite, a small group of British scientists and military officers sit across from their American counterparts. The atmosphere is tense, bordering on hostile. The British team is led by Sir Henry Tizard. He looks less like a saviour and more like a tired university administrator. But Tizard is desperate. He knows Britain is losing the technology war. They have the ideas, but they lack the industrial capacity to build them while German bombs are falling on London. He has come to America with a radical, almost treasonous proposal. He is going to give away Britain's greatest military secrets in exchange for American manufacturing power. The Americans are skeptical. They view the British as arrogant and scientifically backward. They assume they are miles ahead in radar technology. So an American admiral says, leaning back, his voice dripping with doubt, "What have you brought us?" One of the British scientists, a Welshman named Taffy Bowen, steps forward. He is holding a small, unimpressive wooden box. He places it on the table. He unlocks the clasp. The Americans lean in. They expect blueprints, maybe a cipher machine. Instead, Bowen reaches in and pulls out a strange copper and glass object. It fits in the palm of his hand. It looks like a clay pigeon with cooling fins, or perhaps a bizarre harmonica made of metal. It has wires protruding from glass seals and a series of circular chambers drilled into a central copper block. "Gentlemen," Bowen says quietly, "this is a resonant cavity magnetron." The American radar experts stare at it. It looks crude. It looks like a toy. It generates microwaves. Bowen continues, 10 centimeters. The room goes silent. The Americans exchange glances. 10 centimeters. That is impossible. The best American tube, the Klystron, can barely manage a few watts of power at that wavelength. To put radar inside an airplane to make the antenna small enough to fit in a nose cone, yet powerful enough to spot a periscope at 5 miles, you need massive power at incredibly short wavelengths. How much power, an American engineer asks, humoring him. Bowen does not blink. 10 kilowatts. Pulsed. The Americans laugh. One of them actually chuckles aloud. It is absurd. It is the equivalent of saying, you have fit the power of the Hoover Dam into a flashlight battery. 10 kilowatts at 10 centimeters is a factor of 1,000 times more powerful than anything the US Navy has produced. If this British toy actually works, it isn't just an improvement, it is magic. Show us the American demands. This small copper puck is about to change history. It is the mad scientist's creation that should not exist. It is the only thing that can turn the lights on in the Atlantic. But first, the British have to prove that they are not lying. October 6, 1940, Bell Telephone Laboratories, Whippany, New Jersey. The atmosphere inside the radio lab is electric, but it isn't just the high voltage, it is the tension of disbelief. The British scientist Taffy Bowen stands next to the test bench. Surrounding him are the best minds of American engineering men from Bell Labs, Western Electric, and the National Defense Research Committee. They have spent their careers pushing the limits of vacuum tubes, fighting for every single watt of power. On the bench sits the magnetron, affectionately dubbed Number 12. It looks out of place among the sleek American equipment. It looks like a plumbing fixture salvaged from a basement. Bowen checks the connections. He signals the operator. Power on. The transformers hum. The air fills with the sharp metallic scent of ozone. Inside the magnetron, electrons are being stripped from a cathode, whipped into a frenzy by powerful magnets, and spun past the open cavities of the copper block, like air blowing over the top of a beer bottle. The output meter on the test bench does not just move, it jumps. It slams against the maximum reading and stays there. The Bell Labs engineers check their equipment. Surely there is a short circuit. Surely the calibration is off. They reset. They try again. The result is the same. This palm-sized device isn't producing the 10 kilowatts Bowen promised. It is producing 15. At a wavelength of 9.8 centimeters, the Americans are stunned into silence. In a single instant, their understanding of physics has been upended. This crude British device is generating more microwave energy than every radio station in New York City combined. It is a technological leap equivalent to trading a horse-drawn cart for a Ferrari overnight. One of the American executives, a man who had spent years trying to squeeze power out of klystrons, stares at the glowing tube. He realizes that the war has just changed. The British haven't just brought a better radar component, they have brought the most valuable cargo ever delivered to our shores. November 11th, 1940, the Radiation Laboratory Rad Lab, MIT, Cambridge, Massachusetts. The race is on. The Tizard mission was a success, and now the sleeping giant of American industry is waking up. But having the magnetron isn't enough. A powerful tube is useless if you cannot build a system around it. A secret facility is established on the MIT campus. It is innocuously named the Radiation Laboratory, to trick German spies into thinking they are working on useless nuclear physics rather than vital radar. Inside, a collection of physicists, astronomers, and engineers are working 18-hour days. Their goal is impossible: take the British magnetron and shrink an entire radar station, which usually takes up a building, into a box small enough to fit inside the nose of a bomber. This is the birth of centimetric radar. The stakes are explained to the scientists in brutal terms. In the Atlantic, the happy time for the U-boats is continuing. The convoys are defenseless. The existing ASV air-to-surface vessel Mark II radar, with its long 1.5-meter wavelength, is failing. The U-boats have deployed a device called METOX, a passive receiver that listens for the Mark II's pulses. It is a game of cat and mouse where the mouse is blindfolded. When a British patrol plane turns on its old radar, the U-boat hears it long before the plane sees the sub. The U-boat simply dives, disappearing before the aircraft can attack. The hunters have become the hunted. The Rad Lab scientists must build a radar that the Germans cannot hear and cannot hide from. The short 10-centimeter wavelength of the magnetron allows for a parabolic dish antenna small enough to rotate inside a blister on a plane's fuselage. This focuses the energy into a tight pencil-thin beam. It does not just see a ship, it can paint a picture of the ocean surface. It can spot the metallic glint of a submarine conning tower, or even a periscope amidst the clutter of the waves. January 1943, the Bay of Biscay. It has taken 2 years of frantic development, testing, and manufacturing, but the mad scientist's box has been duplicated, refined, and weaponized. It is now the ASV Mark III. High above the grey churning waters, a consolidated B-24 Liberator, painted in the stark white of Coastal Command, cruises through the cloud layer. The pilot, Flight Lieutenant John Jack Cruikshank, scans the horizon. His eyes are tired. He has been flying for 8 hours. In the belly of the plane, the radar operator is hunched over a glowing green screen. It is a PPI plan position indicator scope, a map-like display that sweeps in a circle. Suddenly, a blip appears. Contact, the operator calls out over the intercom. Bearing 320, range 8 miles. Cruikshank banks the heavy bomber. He looks out the window. There is nothing but darkness and fog, but the radar does not care about the fog. The magnetron in the belly radome is pulsing thousands of times a second, its microwave fingers reaching out, touching the steel skin of a U-boat running on the surface to recharge its batteries. Down below on the submarine, the German lookouts are relaxed. Their METOX receivers are silent. They are listening for the 1.5-meter ping of the old British radar. They hear nothing because the new 10-centimeter waves are invisible to their equipment. They believe they are safe in the cloak of night. They are wrong. The invisible light has found them. Bomb doors open, Cruikshank orders. The Liberator drops out of the clouds, the roar of its engines finally reaching the submarine crew. But it is too late. The impossible radar has guided the plane directly over the target. The Battle of the Atlantic is about to turn. The hunters are about to become the prey. January 1943, the Bay of Biscay explodes. Flight Lieutenant Cruikshank releases a stick of depth, charges 6 canisters of Torpex, high explosive, tumbling through the dark mist. They are not dropped blindly, they are guided by the invisible finger of the magnetron painting the submarine's location with terrifying precision. The U-boat captain screams for a crash dive, but the ocean around him erupts. The hydrostatic pressure waves hammer the submarine's pressure hull like a giant's fist. Steel plates buckle. Rivets pop like gunshot, pinging around the interior of the submarine as high-pressure jets of freezing seawater slice into the control room. The batteries short out, filling the vessel with deadly chlorine gas. On the surface, the radar operator in the B-24 watches the blip on his green screen merge with the sea clutter and then vanish. It isn't a dive, it is a kill. This scene repeats itself across the Atlantic. The happy time is over. The Black May is approaching. May 1943. U-Boat Command Befehlshaber der U-Boote, Berlin, Germany. Grand Admiral Karl Dönitz stands over a map table that has become a graveyard. The mood in the bunker is funereal. For years, his grey wolves hunted in packs, decimating Allied convoys. Now they are vanishing. Reports are flooding in from captains who survive barely. They speak of aircraft diving out of solid cloud cover, attacking with lethal accuracy in the dead of night. They speak of surfacing to recharge batteries in the pitch black, only to be illuminated by searchlights instantly, as if the British knew exactly where they were. The METOX is silent. One captain reports, his voice trembling. We had no warning. No ping, no pulse. Just bombs. Dönitz is baffled. The Germans believe they are fighting a technological war they understand. They assume the Allies are still using long-wave radar, which the German METOX receivers can detect miles away. If the METOX isn't beeping, there shouldn't be radar. Theories run wild in the German High Command. Spies in the French ports. Infrared detectors. A traitor in the encryption department. They cannot conceive that the British and Americans have managed to generate high-power microwave radar in a device small enough to fly. To German physicists, that level of power requires a tube the size of a man. The paranoia paralyzes the U-boat fleet. Dönitz orders his submarines to stay submerged longer, to recharge only for short bursts. But this slows them down. They lose the convoys. They run out of air. The hunters are being suffocated. But the secret cannot stay hidden forever. War has a way of exposing the truth in the wreckage. February 2nd, 1943, near Rotterdam, Nazi-occupied Netherlands. A gentle snow is falling on the charred, twisted skeleton of a British Sterling bomber. It was part of the Pathfinder force tasked with marking targets for the main bombing raid. It was shot down by flak, crashing violently into a field. German Luftwaffe technicians are picking through the debris. They are looking for code books, maps, or new radio frequencies. One technician, Oberleutnant Wissmann, kicks aside a piece of fuselage. He spots something unusual in the wreckage of the nose cone. It is a smashed piece of equipment, shattered glass and bent metal, but the core is intact. It is a copper block with cooling fins and a strange multi-chambered interior. He does not recognize it. It carries the serial number of a British manufacturer, but the design is alien. He orders it to be crated and sent immediately to the Telefunken laboratories in Berlin. The device is officially catalogued as the Rotterdam Gerät, the Rotterdam device. March 1943, Telefunken Laboratories, Berlin. The leading radar experts of the Third Reich are gathered around a workbench. The mood is not one of excitement, as it was in Whippany 3 years prior. It is one of horror. They have cleaned the mud and soot from the Rotterdam Gerät. They have disassembled it. They have tested the magnetron. It creates microwaves. One scientist whispers, his face pale. 10 centimeters. Another engineer shakes his head. Look at the cathode. The power output, it must be massive. They hook it up. They run the tests. The realization hits them with the force of a physical blow. The Allies haven't just improved their radar, they have leapfrogged German science by a decade. While Germany was refining huge, clunky, shore-based radar arrays, the Allies had mass-produced a miracle and stuffed it into the nose of every bomber, patrol, plane and escort ship in the ocean. The report sent to Hermann Göring and Admiral Dönitz is devastating. It admits a catastrophic failure of German intelligence and engineering. The British mad scientist's box, the Cavity Magnetron, has rendered the entire U-boat fleet obsolete. The cloak of darkness has been stripped away. There is nowhere to hide. By May 1943, the slaughter reaches its peak. In a single month, 41 U-boats are destroyed. Dönitz, recognizing the futility of sending his crews into a slaughterhouse illuminated by invisible light, transmits the order, withdraw from the North Atlantic. The Battle of the Atlantic is effectively won. The supply lines to Britain are open. The build-up for D-Day can begin, and it was all made possible by a copper puck that fit in the palm of a hand. June 6, 1944, the English Channel. The dawn breaks over a sea of steel. 5,000 vessels, the largest armada in the history of mankind, churn the waters of the Channel, heading toward the beaches of Normandy. Battleships, destroyers, landing craft, and liberty ships loaded with tanks and men. It is a target that a U-boat commander in 1940 would have sold his soul for. It is a feast of tonnage. But the waters beneath the armada are silent. There are no grey wolves waiting in ambush. The few U-boats that attempted to penetrate the Channel were hunted down by aircraft equipped with ASV Mark III radar, or destroyers, guided by its surface vessel equivalent, before they could even fire a torpedo. The Atlantic, once the graveyard of the Allied merchant marine, has become an American lake. Over 2 million tons of supplies arrived in Britain in the months leading up to this day unimpeded. The fuel in the Spitfires overhead, the spam in the soldiers' rations, the steel in the Sherman tanks, all of it arrived safely, because the darkness was stripped away. In Washington, Sir Henry Tizard reads the reports of the invasion. He thinks back to the desperate days of 1940, to the skeptical faces in the Shoreham Hotel and the gamble of giving away Britain's crown jewels. The black box did not just level the playing field, it tilted the earth. 1946, Raytheon Laboratories, USA. The war is over, but the magnetron is not done changing the world. Percy Spencer, an engineer at Raytheon, the company that mass-produced the magnetrons for the war effort, is working in front of an active radar set. He pauses. He feels a strange sensation in his pocket. He reaches in and pulls out a chocolate bar. It is melted, a sticky, gooey mess. Spencer looks at the radar set. He looks at the chocolate. The microwaves that boiled the blood of U-boat crews and spotted bombers in the night had just cooked his snack. Spencer sends a boy out to buy a bag of popcorn kernels. He places them in front of the magnetron horn. Seconds later, fluffy white popcorn explodes across the lab floor. The mad scientist's device has found a new home. The machine that hunted submarines is miniaturized, shielded, and placed on a kitchen counter. They call it the radar range. Today we call it the microwave oven. Conclusion. When we think of the technology that won World War II, we often look to the sky at the mushroom cloud over Hiroshima, or the breaking of the Enigma code at Bletchley Park. But the victory began much earlier, in a wooden box carried by a tired Welshman named Taffy Bowen. The Cavity Magnetron was an anomaly. It was a piece of technology that was years ahead of its time, a device so powerful and so small it should not have existed. It turned the night into day. It blinded the Nazi war machine and cleared the path for the liberation of Europe. Every time you heat up a cup of coffee in your kitchen, you are using the engine of a U-boat hunter. You are using the impossible device that saved an island nation from starvation and won the Battle of the Atlantic.